So this presentation will go over valence electrons and Lewis symbols. For our objectives, we will identify valence electrons on an element or ion, we will draw Lewis symbols, and we will count the number of valence electrons in compounds. So valence electrons are the electrons in the outer shells of an atom. These are the electrons involved in bonding, which is why we focus on them. The electrons you would represent in the condensed electron configuration are the valence electrons. So for example, phosphorus has a condensed configuration of neon, 3s2, 3p3. 2 plus 3 is 5 valence electrons. Take a moment and figure out how many valence electrons are on the following elements.
Thank you.
Fluorine has 7 from 2s to 2p5. Silicon has 4, and argon has 9. This brings us to the topic of Lewis symbols. So whenever you write a Lewis symbol, you start by writing the elemental symbol directly off the periodic table. You count the number of valence electrons on that atom. You put each electron around singly, top, right, bottom, left, and then you double them up. So we'll start with carbon. Carbon has 4 valence electrons. So we go top, right, bottom, left. So we have all 4 represented. These electrons are considered unpaired. We'll do chlorine next. So chlorine has 7 valence electrons. We go around and we add them all on. We have 3 sets of paired electrons and 1 unpaired electron on chlorine. Now let's try cobalt. Cobalt is a little bit trickier because remember from the previous slide, cobalt has 9 valence electrons, but we don't have 9 spots. So what do we do? By convention, Lewis symbols only use the electrons with the highest principal quantum number. So in this case, that would be 4s electrons, and there are 2 of them. So the Lewis symbol for cobalt is represented with 2 electrons. This is undeniably a little bit odd. We know that there are d block electrons available. We know that the d block can bond, but we only put 2 on the Lewis symbol because Lewis symbols were developed by organic chemists to use with elements like carbon, oxygen, hydrogen, and not transition metals. In other words, they don't have a d block. So we've adapted them to be semi-functional for transition and rare earth metals, but they do not give the full picture. We'll run into more of that later. All right, so what if we want to count the valence electrons in compounds? The number of valence electrons on a molecule can be combined or determined by counting the number of valence electrons on each element in the molecule and adding them up. So for example, if you want to do water, H2O, you would say I have 2 hydrogens, each of them with 1 electron, so 2 times 1, plus 1 oxygen times 6 valence electrons. 2 plus 6 is 8 valence electrons on water. If you have an ion and it's positive, you would subtract 1, or you would subtract that positive charge. So for H3O plus, the hydronium ion, we have 3 hydrogens with a 1 electron each, 3 times 1, plus 1 times 6 electrons for oxygen, minus 1 for that positive charge, giving you a total of 8 valence electrons. Now, if you have a negatively charged ion, you would add, right, because it's got an extra electron. So NO3 minus has 1 times 5 for nitrogen, plus 3 times 6 for oxygen, plus the 1 for the charge, giving a total of 24 valence electrons. This is going to take a little bit of practice, so guess what's next? Practice! Give this a try for yourself. I want you to pause this, and I want you to count all of the valence electrons on each of these compounds. Okay, so calcium carbonate. We have 1 calcium times 2 electrons plus 1 carbon times 4 electrons plus 3 oxygens times 6 electrons gives a total of 24 valence electrons. Iodate, IO3 minus. We have 1 times 7 iodine, plus 3 oxygens times 6 valence electrons, plus 1 for the charge, gives us a total of 26 valence electrons. For nitrogen dioxide, we have 1 for nitrogen times 5 valence electrons there, plus 2 times 6, which is equal to 17. And finally, for bisulfate, we have 1 times 1 for the hydrogen, 1 times 6 for the sulfur, and 4 times 6 plus 1 for the charge gives a total of 32 valence electrons. All right, so in summary, valence electrons are involved in bonding and can be identified by writing the condensed electron configuration. Lewis symbols are a way of representing the number of valence electrons on an element. You count the valence electrons. For the D and F block, you only use the highest principal quantum number electrons, and you place the electrons around the element one at a time, top, right, bottom, left, and then you start pairing them. For compounds, you count the number of valence electrons on each element in the molecule and add them up. You subtract electrons if the charge is positive, and you add electrons if the charge is negative.